Hi, good evening to all. Let me know in chats, am I audible and visible to everybody? Let me know in chats, am I audible and visible? Am I audible and visible? I'm waiting for the answers. Please confirm me. Do let me know. Am I audible and visible? Tell me, am I audible and visible? Yeah, today's question is super important. Okay, okay, cool, yeah, cool. Glad to see. Glad to see Sahil, Sanket, Ankit. Okay. So now here in this series, we are now running with what? Now we are not running with maths, but we are running with what? In color, you people like yellow. So we are not running with this. Now we are running with arrays, right? And today we have a question like search and rotate a sorted array. And that question already has been asked in a lot of companies. You can see on the thumbnail, right? In all the FAANG companies. And why, actually, eventually, whatever the question I'm covering here are the super important questions which has been repeatedly asked in multiple interviews. So that's why, because these are the important questions. These are some questions which, if you know the solution, so easily you can make the solution of the other solution problems as well. So now let's go to the LeetCode and we'll understand what is the problem statement. And trust me, it's an interesting problem. It's an interesting one. We'll do boom bam on it. Okay. Now I'll open this. Here we go. Okay. Okay, Joginder. Now, and every day I come live at 6:15. I guess everybody knows, right? So, and live classes are better classes because here you have chance to interact. Here you have chance to ask the things, right? So here is one question: search in rotated sorted array. Okay, rotated sorted array. Maybe I'll get this. Yes, here we go. 42.2% is the success rate. Uh, Quite okay, not that bad. Right, now read the problem statement. There is an integer array nums sorted in ascending order. Okay, so they have given you a array which is nums, the name of the array is nums, and which is sorted in ascending order with distinct values, means there is no repetitive value. Okay, there is no repetitive value. Prior to being passed to your function, nums is possibly rotated. Rotated means some elements has been reorganized, and an unknown pivot index k. For example, k is less than or equals to the k, means 1 is less than or equals to the k, and again k is less than to the nums of length. Again such that the resulting array will be nums k plus 1, and blah blah, a lot of theory they have explained you like right here. Like if this is an array, zero indexed array, if we rotate it from the third pivot index, so which means as of now the third pivot index will be 0 1 2 3, which means that what we'll have, we will have, these value will be rotated, these value will be rotated. Okay, these value will be rotated, so which means they are coming at the end. Look at this. So our task is to find what, given the array nums, are the possible rotation and an integer target. Okay, you have given an integer target, return the index of target, means we need to search it. We need to write a searching algorithm here if it is in nums, or if it's not, then it's -1, right? If particular value is not available, then what we write, we write -1, and we return -1. I guess it's fine, right? So now let's see the problem statement. Like say they have asked for the target 0. So what is the index of target 0? This is 4 here. 0 1 2 3 4. Cool, yeah, it sounds good. 0 1 2 3 4. Now again we have target 3, target 3. Now look at this, is target 3 available in this array? No, it's not, then we'll return -1. So now I hope you understand the problem statement, which is like you have given an array where some element has been rotated, which means directly you cannot apply binary search. There is some logic which is hidden, right? And again, we need to find out the element. If element is available inside the array, we will return the index of it, otherwise we'll return -1. Okay, cool, yeah, cool. I'm also reading the chats continuously. If anybody is getting any kind of trouble, let me know. Okay, let me know. So now what can be the logic? What can be the logic? One logic can be, one logic can be a simple, a linear logic, but I'll tell you why you can't write that. Okay, I'll tell you why you can't use a linear search. So linear search means like what I'll do is that I'll create a for loop here. I'll write int I equals to 0, I is less than nums dot length, yeah, dot, not slash, again slash, length. I'm changing keywords, not keywords. Okay, now I plus plus, cool. And what I'll do is that I'll check like if particular value, I'm explaining because this solution is fine but not applicable. That's why I'm writing this, because it's not a big deal. You understand it's a linear search. We just directly iterating in the whole array in one go, boom, right? So now here, if we found it, then we'll return what? We'll return that index I, which means at this index the value is available. Otherwise, at the end, we'll return -1, right? So this could be a simple solution if they haven't mentioned about one thing. Okay, if they haven't mentioned about one thing. लेट हो गया थोड़ा प्रिंस कुमार, कोई बात नहीं. It's good evening, Prince. Very good evening. It's okay. But a number of your peers are very slowly increasing. Yes, people are using their internet and other stuff. But it's cool. Look at this. It's beating 100%. But it's not an applicable solution. Cool. It's not an applicable solution. Ask me why. It's a linear search. Look at this. We are running the whole loop in the whole array, right? And that is taking the time complexity of big of n, because the whole loop is running, like the whole loop is running. Okay, so but that cannot be an ideal solution. Why? Because they have mentioned here, look at this. You must write an algorithm with log n runtime complexity. And log n only we can get from binary search, not from the linear search. But the problem is here is binary search only work for the sorted data. But here data has been rotated. But we can see there are two sorted arrays. One sorted array, second sorted array. But actually we don't know from where it's sorted and from where it's unsorted, right? So that thing we have to figure it out. But it's okay, cool, we'll figure it out because we are the coders, right? We figure out the things. Smiling. Okay. You are the coder. I said that. Cool. So now here we'll write a logic here. Okay. And keep asking doubts here if you have. Keep asking doubts because it's going to be a monologue. Now what was the problem statement? Yeah, I haven't taken the thing is that I haven't taken an input value, a test case. How we'll understand, right? So now here I will take this itself 4 5 6 7 0 1 2. I'll go again, I'll take an array. So we have an array which have some value 4 5 6 7. Reading the comments, if you have something you can ask. 7 and again 0 1 2, right? So anyhow we have to write an algorithm which is in the log n time complexity, big of log n, right? This is what we need to do. And this is only possible through what? The time complexity of binary search. But the problem with us is that binary search only applies on the sorted data, and here we have sorted, but at certain point of place, it has been rotated, right? So we are not very sure. So what we have to do is that, again, we'll apply a binary search anyway, right? But we'll figure it out, like, are we working in a sorted part or we are working in an unsorted part? So how you can ensure that you're working in a sorted part or not? So let's say how binary search work, we figure out the middle element. So what will be the middle element of it? We will assume this is start and this is the end. Okay, calculate the mid, it's a 0, as of now, its end will be the length minus 1. So the element are the last index will be 6, right? It's 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index, right? So it's a 6. So what will be the middle value at the, so mid will be at the third index, right? Which is 7, which is 7. I want to ensure that is this array sorted or this array is sorted. Because if this is sorted, then I can apply a binary search to it. Yes or no? And if this is sorted, I can apply a binary search to it. Right? So that's what we have to write binary search logic 2 times. But by checking the condition, if particular mid is, is greater than the left, right? So that will be a logic. That will be a logic. So what we have to do is that we have to do 2 to 3 things. First, we have to figure out the mid. Once we have the mid, then we have to figure out we have to check the sorted part. That if we are applying a sorting algorithm, if we are applying, let's say, a binary search, so that particular part is sorted or not. That's what we have to check. And if we are confirmed that this part is sorted, we are going right, we are working fine, then in that case, we can write the binary search right there. Yes or no? Isn't it? So what I will do is that here again, this problem is really tough to understand for a lot of people in this solution. But again, once you will have the code, once we'll put the dry values, once we'll put the test cases, you'll understand like how things are working. But now we have a common idea in our brain that we want log n, which means we have to go with binary. Second thing, because it's so rotated, so anyhow we have to find out, we have to check like a particular patch is sorted or not. So that's what we have to do. Cool. That's what we have to do, right? So now let's go on the code window, which means on the LeetCode. So now here I'll go to the code window, and again we will start writing, because this solution is not good. Yeah, really it's not good. It's working, but it's not good. Why? Because they have already, especially they have asked to write the solution in log n. Nobody will accept it. Okay, nobody will accept it unless it's a somebody is not monitoring anything. So now for binary search, what we need is we need a start value. Everybody knows already, right? Binary search, everybody knows. I strongly believe. And again, we need end value. We have end value. Again, how long we run a binary search, until unless start, is until when the start is less than the end, till then it will keep running. If this becomes larger than the end, it will not execute it, right? And anyhow, we need to figure out the mid value. So int mid is equals to what? Tell me the logic for the mid. Somebody tell me the logic for the mid. Start plus, and I can write the another thing as well. I'll write later on, but as of now we know how to calculate the mid. I'll write this only. Okay. Now here, if we have mid, okay, try to understand this. If we have mid, let's say we have 7 as mid, but we have to check if the left part is sorted or the right part is sorted. We have to check this, right? Only then we can write our binary search. Otherwise, we cannot write the binary search because this data is not sorted. Once we have to figure out the sorted window. So how we can do this? We can come here, we can check that if what? Tell me, if our nums, not ARR, if nums left, which means the first element of the array, it is smaller than or equals to nums mid. Okay, which means the whole left part. If this is, tell me, if this is smaller than this, which means that this window is sorted. This window is sorted, yes or no? This means this window is sorted. This 4, 5, 6, 7, right? If this is sorted, now here we can apply a binary search by putting few pointers, right? So now we are inside binary search, but before moving here, in binary search we always write a condition that if at any point of time nums mid is equals to what? Tell me in binary search. If this is equals to target, which means we found the value, in that case we return the mid. We return what? We return the mid. That's what we do. Tell me, that's what we do. Yes or no? That's what we do. Correct, Sanket, correct. Now here, if we know that this half part is sorted, now we'll write the logic here that if, again, there are some few conditions. When I'll dry run this, you'll understand like why I'm writing this even. So when I have to check like, is my left also less than the target value? Because anyhow, if this target, let's say it's a 0, right, as of now, and if this is not left is not less than the target value, so there is no meaning to search in this window. Yes or no? Tell me. There's no meaning of searching in this window. So anyhow, what we have to do is that we have to write a logic that anyway target should be, if left, the nums left, okay, the nums left, even if you will keep writing the solutions from here, now after a certain point of time, you will be super capable. Target, but success takes time, nothing comes right over the night. So now if nums left means the leftmost value is less than the target value, which means we are working fine. If this is not, then we are working on the wrong place, right? So we'll do something else. Now here, again this, but target should also be less than or equals to the mid. Why is that? Why is that? Why is that? Because this is the one condition which can ensure this array is sorted and we can find the value inside this. It's the one condition. Why? Because look at this, if target is 0 and again maybe the both some another value, right? That maybe leave it, but that cannot leave this one. Target must be less than to the mid. If this is less than, only then the value is available in this part, otherwise value is not available in this part. So if value is available in this part, I'm assuming a scenario. Augustine, hi Augustine. Sir, can you explain in the Python? Augustine, I'll think here. Actually, no, as of now, very few people are joining this. But when I'll see a good number of people who are asking for Python, I'll cover in both, in Java and Python. Okay? Because if I'm putting some effort, at least it will help a lot of people. Okay? The day I'll see at least 20-30 people writing here Python, we'll continue in that. Okay, Augustine? And I hope you have classmates if they are learning Python, people. Okay, Augustine. Now here, look at this. Now here, again, the thing is that if particular value is less than, means if target is greater than this left value, which means value is something in this. Again, the target is less than or equals to this mid, which means value is in this particular range. But if this is not true, which means value is not here. Right, but if this is true, which means we will not search in this part, in the remaining part. So if you don't want to search in the remaining part, what you have to do is that you have to update the end, and end should be mid -1. That's how you write the binary search. Yes or no? That's how you write the binary search, right? And again, tell me if particular value was not in this. So is there any meaning to search in this part? No, we'll directly move to here. As of now, start at 4, but I want now start at 0 because in this part there is no value, there is no target, because it's a particular condition. If this condition is false, this means at the left part there's nothing to do with. So now I'll go to the else part. And here what I'll do is that I'll update my start. Right? Because we don't have to search there. Correct. Sir, I don't know about data structure algorithm. So do I understand this series? Of course you will understand, but what you have to do is that other I have covered 8 to 10 videos always previously. So watch them once again. If you'll watch them, you'll try to put the efforts. At starting, nobody directly understand the problem solving. It comes eventually with time when people keep spending their time. But anyhow, problem solving is the one thing who can give you the package of in huge numbers. Maybe at a fresher maybe 15 LPA, or at the senior level maybe 45, 50, 60 LPA, right? Anyhow, series is super important for anyone. For problem solving, it is super important. So now if a particular value is not available at left, so I'll change to the right. So how we'll go to the right? By doing mid +1. Right? Because anyhow start was here, start was 4. At 4, I don't want to start here. I want to start now here, because in this section my target value was not there according to the previous logic. Yes or no? So anyhow we will not get the value. Anyhow at the end we will return. I'll tell you a edge case here also. This code is not perfect, fit and fine, but I want to make a mistake to make you understand like why it's a mistake. Okay, so after DS the learning, in which after DS then learning this, which is better? Yeah, both the things. Again, data structures you cannot learn without practicing. So I will suggest you should clear your fundamentals of data structures and then continue here. Okay. Or anyhow, if you have the understanding of the any like programming language, then this can also help you. So now I'll run this and see it is working. Oh no, what happened? We cannot get the symbol left. Actually, every day I write a lot of solutions. I even forget like what I mentioned at the top. What was our mentioned value? Start was mentioned value. And everywhere I've written left. You can see the brain is working automatically. Cool, yeah. I've also become AI. Automated human. Cool. That AH, right? Cool, yeah. I'm kidding. So now start. Cool, I guess. Now let's run this. Okay. Now run this. Yeah, Java is better for developers. I highly suggest it because anyway, if you are doing DSA and in Java, so then you can pursue your career in backend in Spring Boot. So you will have a language advantage as well. So now what we have done is that our first case is test case is not working fine. We'll see where we are doing wrong. Cool. So now we have written here everything correct and fine. Okay, so why this case is not working, we'll try to try run it and we'll figure it out. So nums mid is equals to target, this is target, then return it. Otherwise, if nums start is less than or equals to mid, then we do this thing. Cool. What is the thing? Nums start should be less than or equals to the target, or target should be less than or equals to the mid, which means the left part. And if this is the case, then end should be mid minus 1, and because we are searching the left part, which is correct, the starts would be this. Starts would be this, right? Okay. Are we missing something here? Are we missing something here? Oh, actually, end I have written here 0. Oh, end is 0. End is what? Nums dot length. I'm telling I'm running in automated mode. Length. Cool. So now, okay. Now we are not length actually. The end will be length minus 1. Remember, we have created the logic on the whiteboard. Length minus, because last index always is the length minus. Now run this. Now run this. Yeah, I'm just coming after delivering long lectures here. But cool, it's cool. At least we know like how code is working. Now test case has been passed, but is the solution correct? I don't think so. Let's run this. Let's run this, and we'll see, because I want to show you a test case. Oh no, Ajo bhai, come. I'm waiting for you. Give me an error. Cool. Time limit exceeded, right? Time limit exceeded, which means that still there's something which is missing in our logic. What is this? We have 5, 1, 3. Put this in our code. Okay, put this in our code and understand why this will be a time limit exceeded problem. Why we have this problem. So now what will happen? What will happen? You can see this was, like this has been rotated like this. Previously it was 1, 3, 5, but now it has been rotated. Now if we will put the value, we will get mid as 1. Tell me, the mid will be 1, means the index will be 1 and value will also be 1, right? So at the 1 index, we'll see the target which is 0, which is not true, right? So 1 is not equals to 0, which means this is false. Now we come here at the start part, we see like is it start less than or equals to the mid? No, it's not. It's not. Tell me, it's not. This condition is not true. And if this condition is not true, which means this if will not execute as well, which means this while loop will keep executing, and after a particular time, what will happen? We will have an error, time limit exceeded, which means now we have to handle a scenario when start means when the first element is not less than the mid element. We have to handle that scenario as well. So now come here and again write the else part and again write the binary search. Okay. Now base case, there is no base case, we already covered. So now, because that will not be handled like this, because you see a lot of test cases also are there. Trust me, that is genuine problem. You'll try. Your voice has distortions. Actually, maybe a PC is running nearby me, making a sound. But anyhow, very soon I'm sitting in a new studio, then my voice will be more clear. Okay. Now here I have to write the logic again. the logic, if the my left value or the first start value is not less than the mid, then we have to check for the second part, right? We have to check for the second part. So which means I'll write the again binary search if nums, which means mid for the second part. Yes, if mid is less than or equals to target, yes or no, target, and and nums nums not nums, actually targets will be less than nums, right? Yes or no, or end target should be less than target should be less than or equals to the end value, because if this is not coming in this left range or not coming in the right range, which means the element is nowhere, right? So after this scene, so we have to modify the normal binary search by adding extra checks for the sorted subarray. Correct, Ankit. Correct, Ankit. I'm happy that you observed something. Correct. Now, now here we have written the condition, which means if this is true, which means the value was not present in the left part. When the start value will not less than the mid bound, then how value is available at the left? It is not available at the left, right? So what we have to do, we have to search in the right part, in the right after the mid. So how you will do this? You will write start here. Wow, it's a caps I guess. Start, cool. So now start. So we move to the right one, which means mid plus one. You remember, and if this is not the case, then again we'll search in the left part, which means mid should be not mid, actually end should be mid minus one. That's how we write the binary search. And the people who have understanding of binary search, I believe, are understanding the solution here as well, right? So this will be the case. Now how this will handle it? Let's see. So now we have received mid one at the bar index. We're getting one value, which means this start was not true, which means this hasn't executed. Now comes to the else part. So what will happen at mid which is one? Is this less than the target? 0? No, it's not. Which means this will not execute. This else will execute. So the else means the end will be updated. End will be mid minus 1. So mid is what? Mid is what? Tell me. Mid is as of now 1, and 1 minus 1 becomes 0. So now start and end both are 0. Come here. Cool. Come here. Figure out the mid. So now this time mid will be what? Mid will be 0. Yes or no? 0 by 0 plus 0 by 2 becomes 0. And now if this is 0, so again is the value equals to target? No, it's not. Again, see the start value is still 0. Is 0 less than, it means start value is 0. At 0 index we have 5. Is 5 less than 0? Tell me. Is 5 less than the mid value? And mid value is what? Mid value is what? Mid value is 0 plus 0 was 0, we value 0, right? Mid value was 0. So now at 0th index we are getting 5. So is 5 equals to 5? Yes. So this means this, if it's true, now come here. Is the first value less than or equals to the target? No, this is not. Right? So which means else will execute. Now start will be mid plus 1 means 0 plus 1. Now start is 1 and is 0. Check the value. Start is 1 and is 0. This condition becomes false and we will terminate the loop. And at the end, if this will not execute, we will have minus 1. You will have what? Minus 1. So that's what the logic. You have to modify the binary search for two scenarios. First, we have to figure out the sorted part, and again, we have to check like if particular value is available at the left or the particular value available at the right. And if you figure it out, you can find out. Okay. And again, trust me, this problem statement is not super easy to understand. That's why it has been asked in a lot of companies which offers the packages of 45, 50 LPA. Right, look, it's 100%, and the time complexity of this problem statement is big of log n. Why? Because we are managing the binary search. Every time the input value is reducing by half, and when the input value is reducing by half, then it's a logarithmic time complexity, which means the solution is now applicable. Cool. I hope you understood this. Okay, I hope you understood this and you enjoyed it. Okay, and again here I'll highly suggest you that if you're feeling like this was a little tough, You can watch this video again and you can write this solution by your own. You can pass these input values here. You can pass the input values. You can see like how it's working. Even if I have explained how things are working in the code itself. Okay. See you guys. Prince, yaar, my salary. Don't ask these questions. But at least I'm paying income tax more than a lot of people. You know, more than a lot of people's salary. But which is fine, yeah. Which is fine. Okay, cool. See you in the next live on Monday, not on Sunday, on Monday. Okay. Bye bye, guys. Bye bye to all. Bye to all. I hope you enjoyed this. Okay. Cool, yeah. But anyhow, salary doesn't come automatically. You have to spend a lot of time, a lot of hard work, a lot of rejections you have to face, right? A consistency requires, only then you can have a success in life. Okay, cool here. Bye bye. Bye bye to all.